Today's objective is to be able to subtract polynomials by distributing and combining like terms. We'll be reviewing subtracting polynomials given to us in the form of a word problem. So here we have subtract 3x squared minus 5x plus 8 from 2x squared minus 4x plus 3. Now automatically from the keyword, I know that I'm subtracting these two things. I know that I'm subtracting because, well, here it's pretty straightforward. It tells me to subtract one thing from the other. So automatically I already know what operation I'm working with. Now, just because in the word problem the polynomials are not in parentheses does not mean that they are free from them. You always have to set up your parentheses first before you can simplify. So if I'm adding, my parentheses will look something like this. Or if I'm subtracting, then my parentheses will look something like this. Either a plus sign in between them if I'm adding, or a minus sign in between them if I'm subtracting. And again, even though they're not in parentheses in the word problem, you still have to set them up this way. Since I'm subtracting, automatically I know that I'm going to have one polynomial minus the other. Now I have to figure out if first, does the order of these two things matter? And second, if it does, which polynomial I'm going to put in the first set of parentheses that I have here. Now remember that when we are adding two things, your order is not going to matter. If I add x squared plus 3x squared, that's going to be the same thing as 3x squared plus x squared. Both of those things are going to give me the same thing no matter the order, only for addition. But when we are subtracting, order is going to be very, very important. If I subtract the same two numbers in two different orders, they're going to give me two different answers. So in the example that I used before, if I do something like 8 minus 3, for example, that's going to be a positive 5. But if I do 3 minus 8, that's going to give me a negative 5. So subtraction, you have to be very careful with how you set up your polynomials. Now, in the problem, there's always going to be a key word that is going to tell you which one to put first. Here it says, subtract 3x squared minus 5x plus 8 from 2x squared minus 4x plus 3. This keyword from tells you to switch the order of how you see these two polynomials, which means that whatever you're subtracting from, in this case, this polynomial here is going to come first. And what you're subtracting from that, which is this, will come in second. So I'm going to put in 2x squared minus 4x plus 3 first in this parentheses. Again, this keyword is telling me to switch them up. And then I'm going to put in 3x squared minus 5x plus 8 over here. So now that I know the order of these two polynomials and I know that I'm subtracting, now I can do the subtraction as I would usually do it if the problem was already set up for me. So I start by adding my 1's over here so that I can free these polynomials from their parentheses. And now I can begin to distribute. So first I have 1 times positive 2x squared. I have positive 1 times negative 4x. And I have positive 1 times positive 3 over here. Now I'm going to go ahead and take this negative 1, the whole entire thing with its sign, and I'm going to distribute it to 3x squared. So negative 1 times 3x squared. Then I'm going to distribute it to negative 5x. So negative 1 times negative 5x. And then I'm going to distribute this negative 1 to this positive 8. So negative 1 times positive 8. Now we can continue with just our multiplication. Now the great thing about multiplying by a positive 1, which we have in all of these first three terms here, is that we get the same exact thing back. So positive 1 times 2 is just positive 2x squared. Positive 1 times negative 4 is just negative 4x. And positive 1 times positive 3 is just positive 3 right back again. But now remember, when we're distributing this negative 1, the sign of whatever's inside of the parentheses is going to switch. So when I do negative 1 times positive 3, that positive 3 is going to become a negative 3x squared. When I do negative 1 times negative 5, that negative 5 is going to become a positive 5x. And when I do negative 1 times positive 8, that positive 8 is going to turn into a negative 8. So all of these three terms have switched their signs. Now that I've freed all of these terms from the parentheses and I've multiplied them out, I can go ahead and start combining my like terms. So I have 2x squared which I'm combining with negative 3x squared. So on the side, I'm going to do 2 plus negative 3. Again, I'm not squaring these two numbers, I'm just adding them. And that's going to give me a negative 1. So I have negative 1 x squared. Then I'm going to do negative 4x, and I'm going to combine that with positive 5x. So I have negative 4x, so I have negative 4 plus 5, which gives me negative 4 plus 5, which gives me positive 1. So I have positive 1x. And then last but not least, I have positive 3, which I'm combining with negative 8. So I have 3 plus negative 8 to give me negative 5. So I'm going to write minus 5 over here. Now these three terms, first I'm checking, are they in standard form? And I know that they are because I begin with the exponent of 2. Then I go to the exponent of 1. And then last but not least, I have negative 5 at the end without any variables. The other thing that you might be asked about a polynomial is, what is the degree of this polynomial? Once your polynomial is in standard form, which it is here, and it's been simplified, your degree, or the degree of that polynomial, is going to be the biggest exponent that you see here. So I have an exponent of 2 here and an exponent of 1 here. Therefore, the degree of this polynomial is 2, because that's the biggest exponent that I see there. So you can say this is a second degree polynomial, or you can say this polynomial has a degree of 2. But here my answer has been simplified. I'm finished. I've subtracted these two things, and I found an equivalent expression to what we originally had up here.